I wrote a poem in the night. I was so excited and pumped about the event, and the thoughts were raging in my head, and suddenly this poem came together. So it's like this: authors don't share, institutions don't care, journals don't dare, and government is unaware. And that's pretty much what we discussed yesterday and today for the whole day. Well, there's 4 entities, right? And actually, ask anyone here, they will tell you that those are the 4 corners of the research quadrangle. Not a single one of them is a problem. The problem is the whole quadrangle, and it's this loop that is pumping the scientific product around. And at every step, there are incentives and barriers to transparency and inefficiencies that feed on each other. My idea was to bring the representatives from the 4 vertices of this quadrangle: the government, journals, institutions, which is universities, national labs, companies, and individuals, the doers, the researchers, as a separate sort of entity with the agency together, so that they could look each other in the eye, talk to each other, and maybe discover each other's inhibitions and misunderstandings about the other people's roles.
So this conference is focusing on reproducibility, and particularly in condensed matter. The question is, what is the issue here? And there are many aspects. There are the easy and obvious answers that, fraud is not tolerated. You can't have dishonesty in the results, otherwise you're just stepping backwards, you're not moving forward.
I think the discussions around what are the norms that we should start to, what are the things we should try to change about the way we do things, that has been the most illuminating, because, we all come with our opinions, and when you're completely thinking on your own in the absence of a dialogue, it's possible to come up with very impractical ideas about how things should be done. And so by all of us talking, it becomes much more clear what the constraints are on any kind of action we should encourage. Yeah.
Seeing actually how, all the way from the editorial boards to the junior researchers, everyone understands there's a problem and they want to find a way to fix it. Everyone here, I think they really want to find solutions to these things that we're discussing. And I think it's nice to see that we're not brushing it underneath the rug, we're actually trying to solve the problem.
Well, it's a general problem that has occurred in many areas of science, in a variety of areas, and I'm glad condensed matter is picking it up. It's a complicated field, and you have 2 aspects of it. You have what Langmuir coined many years ago called pathological science, which is making mistakes in scientific method. Humans do that. And we have peer review, and we look at each other's work. If you do that honestly, we do our best to catch that. And probably all of us are guilty of that a little bit, because we want to follow certain theories. We want to believe our data. The other side, which is, predetermined, fraudulent data creation. And I like to call that, as opposed to pathological science, psychopathical science, because it is really crazy. You are really inventing things, and there's no real reason to do that. And so I think this conference will be good for helping to define those things and helping to start to have best practices in how to deal with it.
I think my overall issue is that when it comes to reproducibility work, it's very easy to point the finger at a few bad actors to say, oh, the problem is that there were a few fraudsters or a few people acting in bad faith, and we just need to find those people and cut them out and we'll all be fine. And the truth is that I think the issues that plague condensed matter physics and most scientific fields are quite subtle, and they come down to what our career incentives are, what we reward, what we fund, who we hire, what we publish. And I think addressing those issues is possible, but it's going to take a concerted effort to look at the problem and who can make a difference in the problem and how. So it's going to be a subtle and a long effort, but I think it's worth making, and I think we can do it.
I think reproducibility is important for all areas of physics, for all areas of science. I mean, ultimately, what's the purpose of publishing, right? From the scientist's perspective, I'm sure there is the piece around, I did this, and it's important for my career that I get that out there. We can't ignore that. But in terms of being part of science, it is around putting something out there that other people can build on. So if it isn't reproducible, if it isn't trustworthy, what good is it for the rest of the scientific community?
What does reproducibility mean? That it scales from something just not being true at all to the interpretation being wrong.
Reproducibility crisis, this issue, it was discovered as a phenomenon, not by physicists, but in other disciplines in a big way. And those people made big changes. They made also discoveries about ways to improve things and how to become more consistent, more quantitative.
I'm an experimental physicist. So it means that if I want to reproduce an experimental result, I need to really, from scratch, basically the whole chain, I need to redo the experiment. And that you're talking about months of work, I would say typically, and hundreds of thousands of whatever currency you prefer.
So I think this is a good opportunity to really think through how we can support this. And it has many stages. Who should do the work? Who should fund it, and who should publish it? And these are basically the three aspects of this challenge.
The main problem we have right now, there is no culture of reproducibility in our community. Whenever we do an experiment on a topic that other people have worked on before, it is not enough to just show that you achieved the same result, or using the exact same procedure, you arrived at something different. That is considered non-original. So there is this word, this vibe of originality that needs to be there, present everywhere in everything we do.
Exciting results, people will try to reproduce. The non-exciting results will probably less likely be reproduced.
If you discover something new, you get much more credit for it professionally than if you discover that another claim that was made is not correct. And it's very hard to correct that. Like, it really comes down to what are people excited about, and people are going to be more excited about something that's new than about overturning something.
This is a completely overinflated notion, because simply put, most of the research we do is not very original. It is just research that we carried out, and typically for years, 5, 10 years, and we cut it up in small bits and pieces, and a lot of that is not so original.
It would be great if it were more rewarding to put negative results out there in some way that's not a tremendous amount of effort. Would be very beneficial.
There really needs to be a concerted effort to make policies, to make awards for replication work, and that's part of what this conference is about. What's going to work? There needs to be a real effort to reward stuff that doesn't get people as excited, but that's healthy for the field.
I think we need to think about our funding schemes and what we fund and how we fund, because this is kind of the engine of creativity.
Funding agencies should definitely fund people to reproduce work. And I think also perhaps we should end up having at least some kind of grants in that sense, that we don't just chase after high risk, high reward research, but we say, look, let's reproduce it's particularly important results. Let's try and reproduce this.
It used to be that reproducibility very quickly was important. The experiments are much more complex and harder now, but we do need to really reward for someone trying to reproduce a difficult experiment. I'm not sure how to do that. We're writing that in the reports right now. So it's been a great conference.
We don't know the extent to which results don't reproduce. We don't know the extent to which there's misconduct. We have a few cases where it's pretty clear that there's problems. And I think, many people may know things, but that may not be public knowledge.
A very large fraction of theoretical claims are somewhere between correct and incorrect, that they're not as general as one might think, or there's some very subtle issue. So when you're a theorist, you learn to have a lot of skepticism about other theories, to really evaluate them critically. And then there's sort of a culture of theorists tend to just take experimental results as correct, and experimentalists tend to just take theories as correct, and we don't apply skepticism to the other side very much. So there have been many times where I have tried to repeat someone's theory and realized that, it's not quite what they're saying. It's not as simple as what they're saying. It's not as general as they claim, and that feels normal. I have looked at experimental data kind of closely a few times and decided a few times that I don't think what they're seeing is what they claim they're seeing.
It's attractive for scientists to say, let's be scientific. Let's put on the table what are the criteria, and let's make them mathematical. But the truth is, the samples are so rich and we obtain such amounts of data that whatever set of criteria you put on the table, I'll be able to find in my hard drive the data that will fit that criteria. And then at that point, it's a Nature paper, and there's a mission accomplished banner, and the cycle starts over, right? The unreliable work just receives another go around the sun.
The issue is that when these high-profile papers, which are wrong, get out there, they lead research in the wrong direction. They cause other people to embark on things which are effectively hopeless because they're built on a foundation which is wrong. They will never work. This is research which should never have been done, which may well guide away from research directions which are much more promising, and which cause researchers to invest time, also money, in the wrong directions.
Students will be told to go after certain things that aren't possible. And so it really damages science. It damages people that are working in it, especially young people. And unfortunately, the bad press, even though we should put it out on the table, I worry about it discouraging young people to go into the sciences. And don't, because it's great.
I think the journals have a lot of responsibility, and they're not necessarily keeping to their side of the bargain. So I think it's important that journals really up their game when it comes to reproducibility. There's definitely more of an incentive in high-impact journals to not tell the full picture.
In some cases, too much emphasis can be placed on a Nature publication, for example, if it's for career decisions, and that is not a responsibility that we should have, nor indeed a responsibility that we do have. That's a responsibility in a way that the community places on us. But ultimately, researchers should be judged by the quality of the work that they produce, not where they publish. Using a publication in Nature as a proxy for assessing the quality of research or the importance of research that any one researcher produces is dangerous.
Frequently, the the hyped up claims get published in the higher profile journal, and then the other claims have a harder time receiving the same visibility.
So I think the reasons that the paper was published in a selective journal have to be clear. And usually that means that, or always I think it means for an editor, that it's clear that the paper is interesting. It's clear that it's going to inspire questions, and it's clear that other people are going to want to work on this. It's clear that people are going to be inspired by this result. It's going to make them think. And that, in a way, creates a bias for positive results.
I think it's sometimes the case that journals such as Nature, because of their selectivity, because of their high rejection rates, and the fact that we're rejecting so much good work, can be seen as the enemy. And I really, really hope we can get past that, because we're there to support the scientific endeavor. We're doing what we're doing because we love the science, and we really, really want to help researchers make the most of the amazing things they're doing.
I think it's important that people understand the benefits of sharing data, and that it's done in a way that doesn't put burden on them, that there's some entity that oversees it and makes it easier for people to share.
We've come a long way in the last several decades in terms of, everything becoming digital, the internet allowing data to be shared, all of these different platforms for bringing researchers together and sharing data have developed in the last few decades. So it's an exciting time. Things are developing quickly, and there's a lot of opportunities to make data sharing possible in a way that just was kind of inconceivable as even a thing, several decades ago.
In some cases where I requested data, it was clear to the person that I requested it from that I had critical doubts about their experiment, and they simply refused to share data because they are not looking forward to receiving that criticism back and having to deal with it.
There have been at least 3 or 4 times that people have emailed me and said, they think something's wrong. I don't get the same answer. Could you share your code or whatever? And I do. I want to be part of finding out what I did wrong if that's what happened.
I think we have to recognize we have a complicated ecosystem, right? We've got the researchers, we've got the funding agencies, and we've got the publishers. And these are all sort of intertwined, and no one of them could do it on their own. So I think, first of all, we have to recognize that anything we do has to sort of be mutually agreed with these communities. And I think data availability is one example of that, where all of the different parts are starting to work together and develop somewhat complementary policies.
From my point of view, it needs to be done through institutional levers. It can't just be everybody take their own responsibility for their own data, because otherwise you're never going to get field-wide consensus or field-wide results.
If we could provide the community with guidance, I think that would make it much easier for everyone to share, reuse the data, to follow basically the fair principles of data sharing.
I think it's hard to set, these very strict, universal rules of what to do. I think what makes sense is to try to shift the norms in the community to a situation where just sharing your data whenever possible, as much as you're able to, should be the norm. And, not doing that should be kind of, going against the grain.
If you asked me 5 years ago, 10 years ago, maybe even 5 years ago, would you share your code? I would probably say, well, I don't know. We developed this code. This is kind of what we have worked on, and this is what we use to solve problems. Why should I share my code? Because, that's my tool. Should I just give you my hammer? Or, but I think I have, seeing all these discussions, I have actually evolved in that. And I know colleagues that still don't do that because they think, this is something that they have worked on and this is their bread and butter. And so we've been trying to be sort of more open and sort of create code that is shareable and put it out there when we publish results.
Data sharing enables collaboration. And if you're collaborating with people who are not necessarily in your lab, you might make greater discoveries than if you're by yourself, because you're getting diversity of perspectives, diversity of ideas. And I think that on its own should be a pretty good reason for why you might want to share data.
Without that sharing, we're basically inhibiting means of correcting mistakes. And mistakes happen, honest mistakes happen. And, if there's more tools to find mistakes and correct them, then we do better science.
It's very hard to say what percentage of work in condensed matter physics do I think is unreliable. I might guess 10 to 20%. Something like that is just technically incorrect for some reason. But that's more of a feeling than anything else.
I think we are looking in the tens of percents. I find it a very difficult question to answer, but if I would guess, I would say 30, 40%, somewhere in that ballpark.
The numbers there are quite high. They're not less than 10%. They're certainly more than that. You can see things like 20, 30% of people saying, hey, I've been exposed to some practices in the lab that give me pause about how we decided what data to present. So I think that gives you a sense, but it doesn't necessarily reflect the degree of the problem.
If I was to put a percentage on how much of science is unreliable, that would be hard for me to do, particularly given my editorial experience as a journal like Nature. Nature is a very high-profile journal, aims to publish the best of the best, hopefully successfully so most of the time, maybe 2-3%.
So in terms of raw research coming out, which is unreliable, I think it's a very small percentage. But it's very high profile. So in terms of profile, I think it's a very significant percentage. I think the higher the impact factor of the journal, the more likely it is that the result is either wrong or, at a minimum, oversold and exaggerated.
Now, the more dangerous issue is to what degree is there work that is technically flawed, that is literally incorrect because of some technical reason or even because of bad behavior, data manipulation.
So I have a slightly different view on what is exactly the reproducibility problem that many members at this meeting. I actually think there's a lot more bad intent than some other people here do. I think there is a very strong publish or perish culture being pushed right now. There is a lot of industry funding, which is no longer, let's try stuff and see what we find, but is really, here's money, make this happen. And I think this is really incentivizing people to be very creative in finding ways to make things happen, or at least to make it look like they made things happen. So, and I think this is a big problem. In many of these cases, the reason I don't view this as a real reproducibility issue per se, I would if I thought in most cases the authors were not aware that their results are irreproducible. But in most cases, I believe they know they're not reproducible.
Often people that they're up against the wall, they're looking for a job or they're in a difficult situation and they need to get the publication out. And that's when people start falsifying things. And that's when you get the fraudulent cases. Most physicists don't go into science to do fraud, but they can end up doing it.
I think it is very clear that the incentives are there for someone to get published and advance in career and please their supervisor, and that also science is hard. And if you're working in a lab on a project that it may not be well conceived, it's hard to keep going to an ambitious, charismatic supervisor and telling them this isn't working and I'm not seeing what we want to see and I don't think we have the samples of the quality. Maybe you feel comfortable saying that at the beginning, but after a while, your career progression is in jeopardy. We know that in every field, there's people of sort of different characters, and we know that, many people will lie when they come under an amount of pressure or they're in a tight spot.
There will always be people who will choose the easy way to get results, making them up on a computer. The question is, how can this be controlled? The universities should, and in most jurisdictions I'm told, are required to report all allegations of misconduct to their funding agencies and to their oversight boards. We've heard several stories, I've also experienced some, where they apparently do not, and nothing happens. It seems to me that if a funding agency has this requirement, or if an oversight board has this requirement, and a university does not report such an allegation, their funding should be cut. Not shortened, not cut. They made an agreement to follow it, and if it's not done, they should lose the opportunity to get funding. So there needs to be an enforcement and a punishment mechanism.
I know that this idea will be somewhat controversial among physicists, but I do think there's a problem with organizing the physics community so strongly by PI group, with people who are very dependent on, and the person leading it as well, very dependent on certain programs of research succeeding and having positive results. And you also have institutions which raise grant funding through this mechanism of sending those PIs out as their representatives to apply for money or to publish, and they promote them. What institutions don't do is have any kind of internal review of their PI work. If we organize in this way, we can send the PIs out to aggressively raise grant funding and bring publicity to us, which accrues to the institution. And then if there is bad science, or if a PI or a postdoc or a student either fabricates data or creates a huge mess of error or incompetence, that's on them.
If you think that there's a problem, a mistake or fraud, it doesn't necessarily mean there's something wrong. There should be a policy to at least look into it without, if you make an accusation, you don't want to immediately say this person is wrong. You quietly do an inquiry and decide if there's grounds for an investigation.
I think the best thing we could do, and I assume it's one of the things we're going to do at this conference, is think about what are the best practices when you're in the research lab. The moment you decide you're going to do an experiment, does everybody understand what they're trying to do, what they're going to do when they see an interesting effect? How are they going to confirm it? What are the basic checks that you need to do? And that largely starts with the PI, the mentor. How is that person going to convey to their students, okay, you've seen this interesting thing. Now how are you going to check it? If we know that that's part of the culture and we can support that as journals, and the funding agencies are supporting it, then we can start to create policy and structure that helps support those questions. We can invite reviewers to say, do you feel like all of the necessary checks were done here? Do you have faith in the results? If not, what's missing?
A retraction is today always considered something bad, right? And I'm not sure that's correct.
We shouldn't stigmatize them, right? If people make mistakes, then there shouldn't be shame associated with correcting the mistake. Instead, it should be seen as sort of being honest and transparent with the scientific community. So anything we can do to remove that stigma for the honest mistakes, we should be doing.
If you decide to retract your own paper because you think there's a problem. Nowadays, you can publish another paper and say why that's happening, and you could link them.
If it's coming from the authors and they're asking to retract their paper, that usually goes pretty easily, right? It's when there's disagreement. And then, we have to stand by the retraction in the same way that we tried to stand by the original result. We have to make sure that the reasons that something is being retracted make sense and we can stand by them. And we also want to be very careful that we don't damage reputations unnecessarily.
There can be a tendency to become very cynical about these issues. And I think that makes it difficult to have a dialogue with each other, because all of the people that are coming at this from different sides, we have journals, we have people in ethics offices at universities, we have researchers, we have students and faculty. By and large, people are trying to do the best that they can within the constraints that they're operating. Now, it doesn't mean we shouldn't call out bad behavior when we see it, but I think trying to avoid cynicism will lead to a more productive interaction between all of these different people.
Do I have hope that we can fix the problems? Yes, one should always be hopeful. At the same time, you realize we're humans. This is human nature. It'll never be fixed. But we can try to improve things for sure. And if you've got your eyes on pursuing the truth, then that's going to involve correcting errors or inaccuracies along the way as well. Yeah.
The people that came here out of a lot of goodwill and with the intention and desire to make things better.
I'm an eternal optimist that we can fix anything we set our minds to. I think what's needed here is a critical mass of the community coming together and saying, we need to talk about this. And it really does have to ultimately be community-led, right? And I think conferences like this are really important because you have to be noisy if you want to make change and you want to make people think about things differently.
We're absolutely ready. We are ready to make the change. And hopefully this conference will be one of those starter guns, like let's go, let's make the change.